Hi guys, I'm going to quickly go through an example problem for calculating unknown forces, going through the whole process of more complicated FBDs, okay? So here I am looking at our unbalanced force particle model, worksheet 1, because I needed a really long title apparently, okay? And I'm going to go through number 1. So let's take a screenshot of this so that we can get started. Maybe. Yay! Well, it's a little fuzzy, but I think we can read it. Okay, great. Let's use a white. There's no white. It's a gray. Let's use this color so we can write off to the side. So here I am looking at number 1. A 4,600 kilogram helicopter accelerates upward at 2 meters per second squared. Wow, really great information right off the bat. So I'm just going to write off to the side over here. We know the mass of our helicopter is going to be equal to 4,600 kilograms. Great information. We're also told that the helicopter is accelerating upward at 2 meters per second squared. So acceleration of the helicopter is 2 meters per second squared. We're told upward, so I can leave it as a positive number. Let's make our quantitative FBD. So here's my dot representing all of the mass of the helicopter shrunk down to a single point. And we have the force due to gravity. Okay, and we also have, trying to make this arrow look a little longer, force of lift. The reason I'm going to make that arrow a little longer is because we are already told that there is an acceleration upward, so it needs to be unbalanced in that direction. Fantastic. Let's go on and figure out the net force equation. So the way we're going to do that, switching colors over here, let's do a nice blue. Switching colors. Okay. We're going to write a sum of the forces equation. So the way I do that is I say sigma, or sum of, the forces in the y direction, because I'm only looking in the y direction, there's nothing happening in the x direction, there's nothing for me to think about. It's moving, there's an acceleration, so I'm going to say equals ma, from Newton's second law. Okay, not very helpful. Let's make this more specific. Let's think about the actual forces that I have. So I know the sum of the forces in the y direction is this adding force of lift to force of gravity, which is going to equal ma. This is our net force equation. This is what you will be expected to write on tests. Okay? Cool. Still want to be able to figure out lift force, so I think I need to do a little algebra and start filling in my equation. So I'm going to move a little bit over here. Okay. Sum of the forces in the y direction is going to equal force of lift, I don't have a formula for it, minus mg. Okay, we already remember that force of gravity is mg, but because it's in this downward direction, that's why it's going to be negative. Okay, cool. Go back to my blue here. And that's still going to equal ma. All right, I can see that I already have a value for mass. I already have a value for gravity, because I know it, because it's a constant. And we have a value for acceleration, because it's given in the problem. So let's do a little bit of algebra and isolate FL, force of lift, on one side of the equation. So I'm just going to say FL equals ma plus mg. So all I did was added mg and moved it to the other side of the equation. I can simplify this even further because I see two m's. So I can factor those out and I'm left with force of lift equals ma plus g. There's nothing else I can do to this problem, so I think this would be a great time for us to plug in some numbers. So let's move up here for that part and switch over to that light gray color so it's easier to see. F of L equals, what's my mass? 4,600 kilograms. Multiplied by my acceleration, which is 2 meters per second squared, plus gravity, which I'm going to I'm going to approximate to be 10 meters per second squared. Notice I'm including my units. Always include your units. Every time you write a number, you need a unit. I've already done this math, so I can already tell you force of lift is 55,200 newtons. Cool. Let's go back and add that to our FBD so it could be truly quantitative. Okay? 55,200 newtons. Now we need to go back and calculate mg real fast. So we already know our values is going to be 4,600 kilograms for our mass multiplied by 10 meters per second squared for our gravity. So that's going to be 46,000 newtons. Cool. Let's take a look at the problem. Get out right here for this. All right, I have figured out my FBD. It's quantitative because I have numbers. I've written my net force equation, this guy, okay, for the axis along which forces are not balanced. Okay, great. Determine the lift force. We did that over here. We still need to figure out how far the helicopter has traveled in 3 seconds. And for that, let's wipe away everything we have over here. Okay, let's just wipe it all away and just draw ourselves a nice little, a nice velocity time graph so that we don't mess this up. So velocity time. Because as we know, the area under the curve is going to be our acceleration. Cool, so we just need to figure out what the height is and the length. We're asked to figure out after 3 seconds, so this is going to be 3 seconds. If we're starting off at 0 meters per second, and we have an acceleration of 2 meters per second squared, what will our velocity be after 3 seconds? Okay, cool. So we know that acceleration equals velocity final minus velocity initial divided by time. Let's solve for velocity final. Okay? So acceleration times time equals velocity final minus velocity initial. We know this is going to be 0. So I need to do my acceleration times time to figure that velocity final. So let's do that. 2 meters per second squared times time, which is 3 seconds, equals 6 meters per second. Fantastic. So this height's going to be 6. Now all we need to do is figure out the area of the triangle. So I'm going to move over here quickly for that. Okay, we know the height is 6. We know the base is 3. So base times height divided by 2, we have 6 times 3 divided by 2. That's going to be 9. 6 times 3 is 18, divided by 2 is 9. What's our unit? Meters. Great. Now we've figured out how far the helicopter has traveled in 3 seconds. Hopefully this video has been helpful to you. If you have any questions about problems, please email me, Schoology message, whatever you need. Okay? Come into tutoring, iTime. Problems will get harder. This isn't a bad one. They will get harder. You need to get this process down. It needs to be innate. All right? You'll have a good day. Bye-bye.